We're going to dive a little bit deeper into log functions and the graphs of log functions today. So 211 continued logs, but specifically the graphs of them. So we did a little bit of this yesterday. On the left, this is if you have an exponential function, God bless you. And on the right would be a log function, but we're going to dive a little bit deeper into it. So if you're looking on the left at your exponential function, there's two different kinds, right? If the base is bigger than 1, so your base is a whole number bigger than 1, then it is which of the colors that are there? Green. The green one. It is increasing as you move from left to right. Yep. Thanks, Edward. I don't particularly care. It was just a conversation. Yeah. Then it says if it's in between 0 and 1, so this would be a fractional base or a decimal base, right? And that one is well, I'd go far as to say that's purple. Indigo. We'll agree to disagree. Okay. That one is either blue, indigo, purple, whatever we want to call it. Okay. That's that one. So both of them have the same x-intercept or y-intercept, correct? Which would be what? 0, 1, or your x-intercept, a y equals 1, right? Both of them have the same asymptote. It would be horizontal or vertical? Horizontal. And the equation of that asymptote would be y equals 0. Okay? The base being greater than 1, so the green one is increasing. So if my b is greater than 1, it's increasing the entire time. If my b is in between 0 and 1, it is decreasing the entire time. Lower that. If the b is greater than 1, it would not be decreasing at all. So if it said decreasing, it would not exist. If it was the b in between 0 and 1 and it asked when it was increasing, it wouldn't exist. The domain for these are what? Negative infinity to positive infinity. There's no restriction on domain for an exponential function. The range on these is what? 0 to positive infinity, and that goes for both of them. How about concavity? Are these concave up or concave down? Concave up the whole way. Right? If I draw this shape, it is making that U shape. It flattens out a little bit, but it is still making that U shape. So both of them would be concave up. And the end behavior, and this is where it gets a little weird. So if I were to look at the end behavior, and we're going to do it on the green one first. So let me change it. Highlight this color. Green. We're doing limit notation. Yep. So if b is greater than 0, I can go limit behavior, thank you, to the left and to the right. So limit as x approaches negative infinity and the limit as x approaches positive infinity. A little bit darker green. Okay, so what's happening to the green curve as it approaches negative infinity? Good. Sorry, I didn't answer you, but yes. F of x equals 0. Man, it just does not want to get any darker. Okay, and then what happens as it approaches positive infinity? Huh? Yeah, it goes to positive infinity. So for exponential, they're pretty like standard. As you approach the left or right, you're going to get that. And it will change when you get into log, which we'll look at in a second. Yep.
There's no vertical asymptote.
Correct. So it looks like, like it stays on this side, but the bigger the x, it does keep increasing. It just increases by a teeny tiny amount. Yeah. All right, then if you look at the blue, indigo, purple curve, and I wanted to find, so if b is in between 0 and 1, and I wanted to find the limit as x approaches negative infinity and the limit as x approaches positive infinity. What's the end behavior as it approaches negative infinity? It goes to infinity, right? This is going to keep going up. And what's the end behavior as it approaches positive infinity?
0.
Good. Hmm? 211. Questions on any of that? So these questions will ask you a little bit of mix of things. You might see something like, f of x is an exponential function with a base of this. What is your end behavior? And the goal would be to not have to graph it all the way out. The goal is to be able to understand, really, is it increasing or decreasing? That's really all you're looking for. If there, and we're going to talk about it a little bit more with logs, but if there's a reflection or if there's a shift, you want to know what that does without having to plot points and graph the whole thing, okay? All right, so now we get into logs. So our log takes on that shape. It's going to point up and to the right if it's a standard log with a base that is bigger than 1. And a log has what kind of intercept? An x-intercept. So it may have a y-intercept, but if the vertical asymptote is at 0, it's not going to, okay? But it always has an x-intercept, and that x-intercept is 1, 0. This is your parent function. Obviously, there are shifts after this, but this is the parent function. The asymptote is what kind of asymptote? Vertical asymptote. And the equation of that asymptote would be, God bless you, x equals 0. Good. Is this increasing or decreasing? This is increasing from negative infinity to positive infinity, so it would not happen for decreasing. Yep.
Are these like just things for us to know, or like is this an actual problem or something?
It could be both, I would say. Yeah.
How do we know the concavity of this?
Well, look at your concavity shape. It's doing like this, right? Is that making more of a U or is it making more of an N?
Okay, down.
Yep, so this is down.
Orangey grapes.
All right, domain on this log function would be what? 0 to positive infinity. Range on this? Negative infinity to positive infinity. That would be true for any log, okay? Remember, they switch. Domain for exponential, all real numbers. Range for log, all real numbers. And now the end behavior, and this is what changes a little bit, okay? Because there is a vertical asymptote, there is going to be a stop at some point in my end behavior. So instead of saying as I approach negative infinity, I'm going to say as I approach the x value of your vertical asymptote from either the right or the left, depending on where your log is. So this log is getting close to without touching where x is 0, and it's coming from the right side, right? That's where it's closer. It's not on the left side. So when we do the limit notation here, we're going to do limit x as it approaches 0 from the right. That's the left side of this behavior. It's going to hit that vertical asymptote. Yep.
Why do we do it for this one and not?
Say again.
Why do we do right?
Because there was no vertical asymptote here, so these never ended left or right.
Oh, okay.
Does that make sense? Your arrows are going to point, because your domain is all real numbers, your arrow is going to point all the way left or all the way right on these. Whereas this one, this turns and it goes down, and it can never go past that vertical asymptote. So there is a stop to the end behavior on that side. If it was on this side, right, now there'd be a stop coming from the left. Does that make sense? Okay. Daniela.
Isn't that approaching it from the right? Like, is it 0 plus? Isn't that from the right?
So you're saying as it's coming closer to 0 from the right-hand side of your graph.
Oh, okay.
Yep.
I think it's above.
No, if I did, that was wrong. And then the limit as x approaches, now there's no end to this side, so it would be positive infinity. So as it approaches 0 from the right, as it's coming from the right, what's happening to my x value, or my y values? They're going to negative infinity. And as it's approaching positive infinity, what's happening to my y values? Positive infinity. So you see the difference with a log is that the f of x is going to be approaching either infinity or negative infinity, but we change, one of these limits is going to change to be the value of the vertical asymptote. On the exponential function, we go negative infinity and positive infinity on the limit, notation, but then the f of x is going to be approaching the asymptote for one of those values, and then positive or negative infinity for the other. Does that make sense? So just looking, because it's one of the questions you're going to have to answer, here's the end behavior of something. Determine what kind of function it is. If my limit is over positive infinity and negative infinity, it's exponential. If my limit is over a number and positive and negative infinity, now it's a log. Does that make sense? Yes? No?
Yes.
Okay. I got 2 nods. I'm moving on. Okay. All right, so then to graph, and we talked about this briefly yesterday, but there are 2 methods. The first is find the exponential inverse, find the coordinate points, and then switch your x and y values. And I would say that that's easy for something that's a basic log. Like log base 5 of x, maybe not so bad. Just do 5 to the x, find your coordinate points, and then don't forget to switch them. Method 2 is convert your log into exponential form, and then plug your values into the y instead of the x. So we're going to kind of do both in a minute. These are all your translations and dilations, same as every other function we have done. If you are adding or subtracting after or before the function, but it's separated out by a plus or minus without parentheses, this is a vertical shift. If it's positive, it goes up. If it's negative, it goes down. If it happens inside the parentheses, now it's a horizontal shift. And this is the opposite your brain thinks, right? If it's positive, it goes left. And if it's negative, it goes right. This also determines your vertical asymptote. So if there is something inside the parentheses, you set it equal to 0, and that's where your vertical asymptote is. If there's nothing there, then your vertical asymptote is at x equals 0. Sure. If there's a negative on the front of your log, it flips it upside down. So where my typical log is going to look like this, a negative reflection is going to flip it upside down like this. If the negative is inside the parentheses on the x, it flips it over the y-axis. So instead of looking like that original black curve, it's going to be pointing to the left. Then comes the dilation, your vertical stretch or shrinking, your vertical stretch or compression, right, comes from something being multiplied on the front of your log. So if that was a number bigger than 1, then it's a vertical stretch. And honestly, it just grows faster. There's not a huge difference on these. It might go like this instead of the original black curve. And if it's in between 0 and 1, it's a vertical shrink. So it might flatten out and make something like this where it's closer to your x-axis. And then the last of them is your horizontal dilation. And the horizontal dilation happens inside the parentheses with the x. And we know horizontal goes opposite. So if it is bigger than 1, it's actually a horizontal compression or shrink, and the factor would be opposite. The factor would be 1 over c. So if I had something like log base b of 1/2 x, well, greater than 1, sorry, let's start there. If I had 2x, then this is actually a vertical compression by a factor of 1/2. Good. And a vertical compression really means that I would take something that's like this and it would squish it. So it also kind of makes it taller. A vertical compression a horizontal compression looks like a vertical stretch. And then if you have an in between 0 and 1 value, this would be a vertical stretch. So if I had log base b of, let me change the color, log base b of 1/2 x, this is actually a stretch by a factor of 2. And if you pulled from the sides, it would pull it faster, so it would flatten it out. So a horizontal stretch looks like a vertical compression, and a horizontal shrink looks like a vertical stretch. There's almost no difference to it, okay? But obviously, you have to be able to, and we do that a little bit more in the next section, look at an equation and determine is it a horizontal dilation or a vertical dilation. So we're going to do both methods, you get to choose. First method is taking your log and finding its inverse. So I will take my equation, I will make f of xy, I will switch my x and my y, and I will then solve for y. So to get it out of exponential, get it out of log, I have to have the 4 come over and pick up the x. Drops off, leaving y minus 5, and then I want to add the 5. And then this is its inverse. So once I find these points, I have to switch them. So I do my x chart and my y, or x and y chart. I plug in for x. I'd get 4 to the negative 1 plus 5, 4 to the 0 plus 5, 4 to the 1 plus 5. Dane.
Do we still, like, for the amount of points we need to, for it to, like, count, how many do we need?
I would say 3 is fine. Unless it asks for something specific, I would say 3 is plenty. So then I get 1/4 plus 5, or 5 1/4. I get 1 plus 5, which is 6. I get 4 plus 5, which is 9. Now those are the points of my inverse. So to graph the log, I have to switch them. These get switched. So the 5 1/4, the 6 and the 9 become the x's. The negative 1, 0, and 1 become the y's. So this was really f negative 1 of x. And I want this to be f of x. So you have to switch it. If you do it this method, you have to switch them at the end. So I get 5 1/6, negative 1. I get 6, 0, and I get 9, 1.
Why is it 5 and 6?
5 1/4. I'm just making stuff up right now. 5 1/4. Then where is my vertical asymptote? Based on the original one, where's that vertical asymptote? X equals 5. So this makes perfect sense, right? My graph looks like this, and I would curve it up to the right. Dane.
Can we just know, like, the root function and know the points there and then just shift them?
Sure. The problem is that you have to shift in the opposite way. And that's why I try to teach that first class.
Like, what do you mean?
Because your shift on the log is to the right 5. But on the inverse, that means it's actually an up 5.
But I'm saying, like, know the original log, like.
So I told him you could do 4 to the x. You could know what that looks like, right? But then you'd have to switch it. You either have to take that function and shift that function, and that shift would be up 5, and then flip it. Or you'd have to flip it and then move it to the right 5.
But, like, what about just knowing the root of just the log for x, and then just shift the points from log for x?
You just have to know which kind of shift you're doing. Are you shifting the inverse?
No, just the.
Or are you shifting the original? Yeah, so that's fine. It doesn't matter, but that's what they got confused on, because I was like, it's not, if you're shifting the inverse before you can totally do that. You can plot your original, the base function,
Yep.
flip it, and then shift it based on the log. Yes, you can do that. They were confused why the shifts are not the same, because if you shift before it, then I don't even want to get into that topic. If you understand that, you do it, but it was like worse for them than even to talk about it. Xander.
What's the other way?
I'm going to do it. The other way is we're going to take our function, we're going to convert it into exponential and plug in for the y instead of the x. So I'm going to take this function as y equals log base 4x minus 5. I'm going to convert it to exponential. So the 4 picks up the y, and then I add the 5. And now I can't, I could plug in for y, for x, but it would be weird. It would be like a guess and check. So instead, I plug in for y. I'd get 4 to the negative 1 plus 5, 4 to the 0 plus 5, and 4 to the first plus 5. 1/4 plus 5 is 5 and 1/4. 1 plus 5 is 6. 4 plus 5 is 9. And they're the same points. This time I don't have to flip them. 5 and 1/4, negative 1, 6, 0, 9, 1. So if I taught you last year, I pushed this one.
You think this one's easier?
I do. But you're in it. The reason why they are so heavy focused on the inverse is because you're in a section in which there's a lot of talk about the inverse. So it's also, there is value to that. You choose. Just don't forget that if you're finding the inverse, you have to switch your points after. And I think that's what the mistakes made here, that people will plug in for y, but then like their brain tells them that they plugged in for x and they will switch those points. So that's the danger there. And the danger on this side is not remembering to switch your points. But just pick a method and stick with it. Dane.
In terms of the root function, like what I was saying before.
Yeah. Let me pause. To be honest, I don't see them saying graph this function.
Okay.
I see them saying, what's the domain of this function? What's the intercept of this function? What's the end behavior of this function? Those kinds of questions. Okay. So you would, 2 points would be plenty. Right. Yeah. And you'll see we're going to do this without even plotting these points because you're just going to understand the shifts. That could be enough to answer it. But there are questions that flat out say graph, so you need to know how to do it. But I kind of don't see it being an open-ended question on your AP exam because I don't see them grading graphs that are hand-drawn. Yeah. All right, so on this question, let's go, now let's answer. Domain is what?
5 to the 3.
Good. How about x-intercept? 6, 0. One way to get it from your graph. Another way to get it from the middle point on your T-chart if you use these points. You already found it. And if you use negative 1, 0, 1, you will already have always found it. All right, how about we said the vertical asymptote from the beginning? It was? X equals 5. Make sure you make it the equation because it's got to have the x equals. It's not just 5. Questions?
Are we going to have to, graph the inverse every?
I mean, outside of this lesson, sure. It could ask you, that was the last couple of sections where we did inverse. Or was that 2.8, right? We did inverse. That could happen. But if it just says graph log, it's not going to say you have to graph the inverse and then get to it. Your goal is just to graph the log.
So that's why
We're not even going to use that option, okay? Go to this. The first one on the slide was option 1, which is actually take this, make it its inverse function, okay? So to make this its inverse function, we switch the x and y. So I replace f of x with y. I switch the x and the y. And I need to get the log by itself, but before I do that, I have to get rid of that 1. Or I need to convert it, but before I do that, I have to get it by itself. So I'm going to add 1. X plus 1 equals log base 4 of y plus 2. And then the 4 picks up the x plus 1 equals y plus 2. And my last step would be subtract the 2. This is the inverse function. So this is now f, was it f? Yeah, negative 1 of x. Now I can plug in. And when I do the inverse, I'm plugging in for the x, because that's where my exponent has the x. So I would do 4, negative 1 plus 1 minus 2, and then I'm going to do 4, 0 plus 1 minus 2, and then 4, 1 plus 1 minus 2. And I get 4 to the 0 minus 2, which is 1 minus 2. I get 4 to the first minus 2, 4 minus 2. And I get 4 to the second minus 2. All right, I'm going to plot these. So these are the inverse of them, right? So when I plot the original, what do I have to do? I have to switch them, which means I'm going to switch it. So the actual function, I switch it. So it would be negative 1, 0, 1, and it would be negative 1, 2, 14. So negative 1, 2, 0, 14, 1. Where is the vertical asymptote? Negative 2.
So everything just flips around.
Yeah, when you do that method. So again, I want to stress that this is getting the inverse. When you get the inverse, you have to switch the points after you get them. The second method, you put this original into exponential and you plug in for the y. So I'm going to take y equals log base 4 of x plus 2 minus 1. I'm going to move the 1. I'm going to let the 4 pick up the exponent. I'm going to subtract the 2. And now, it would be weird to plug in for the x, so hopefully you would remember, I have to plug in for the y this time, because I'd be guess checking the x. If I plug in for the y, I get 4 to the negative 1 plus 1 minus 2, 4 to the 0 plus 1 minus 2, and 4 to the 1 plus 1 minus 2. 4 to the 0 minus 2 is 1 minus 2, which is negative 1. 4 to the first minus 2 is 4 minus 2, which is 2. And 4 to the second minus 2 is 16 minus 2, which is 14. Now I get negative 1, 2, 0, 14, 1. So I would say if that first method confuses you, then don't even touch it, okay? They will talk about it, like if you watch the AP classroom, I think it's confusing. They like to talk about the shifts and how the shifts are reflected differently. As long as you understand that they would be reflected the other way, a horizontal on one becomes a vertical on the other, a vertical on one becomes a horizontal on the other, I think you're okay, and I would stick with one of these. Just don't confuse these. Stick to one. Either make the inverse, plug in for x, and then switch your coordinate points, or get into exponential, plug in for y, and leave your points alone. Yeah. Oh, sorry, Valeska had her hand up first. Go ahead.
Do we have to know how did you
No. One or the other. Yep.
Yeah, I was gonna ask if you were gonna ask.
Nope. One or the other. Yep. And there's not a whole lot of graphing full out. It's more of understanding so there are some, obviously the homework you're going to graph full out. But it's more of the AP style questions are more of like, what is the domain of this function? What's the range of this function? Where's the vertical asymptote? What kind of intercept does it have? So you just have to understand the basic log function. You want to graph the log. But your methods are either make the inverse and then flip your x and y, or put it into exponential. Putting it into exponential is not making the inverse. It's just converting it into exponential and then plugging for y.
Okay, so you
Yep.
find the inverse and then just flip it and then graph.
Correct. All right, what's domain? Good. What's your vertical asymptote? Oh, I skipped one, but what's your vertical asymptote? X equals negative 2. What's your x-intercept? Is there, right? It's the middle point of your graph if you do negative 1, 0, 1. Questions? So if you don't graph it full out and you only get those things, like I would say, I know what an overall shape looks like. I know the vertical asymptote because of the x plus 2 inside the parentheses, right? Then for your intercept, you would be plugging, if you're doing the first method where you're finding the inverse, for the x-intercept, you're plugging 0 in for x, and then you switch it. If you're doing the second one where you're converting to exponential, then you're plugging 0 in for y, and you leave it alone. So you have to understand whichever method you're choosing to do, you have to understand what it means when you find those things. All right, so based on these, we don't want to graph full out. It just says, find the domain and range, the asymptotes, and the end behavior of the following functions. So tell me what you know about the graph of A without actually graphing it all the way out. What's the negative do? Upside down. Over the y. What's the 2 going to do? It's a stretch. Is a vertical stretch going to change my domain, range, or asymptotes? Or end behavior? No. How about the x minus 3 inside the parentheses?
That's your vertical asymptote.
My vertical asymptote is at? X equals 3. This is a vertical shift to the right. I mean, a horizontal shift to the right 3. So if I took my original log shape. Yeah, it is. No, it's not the y-axis. It's the x-axis. If it's inside, it's x. If it's on the front, if it's inside, it's y. If it's on the front, it's the x. So I'm going to the right 3. I'm going to plot my vertical asymptote. And then I'm totally going to do a general shape after that because I don't really need the specifics. We said it's upside down and we said it'd be tall. So if this is regular, then upside down and stretch is something like that. It does not need to be perfect. Because from here, you should be able to say your domain, which is what?
3 to infinity.
3 to positive infinity. Your range, negative infinity to positive infinity. Your asymptote, vertical or horizontal? Vertical at x equals 3. And end behavior. So I've got the limit. What's the furthest point to the left? It's going to be approaching 3 from what side? From the right. So the limit as x goes to 3 from the right. And then to the right, it's infinity, right? So limit as x approaches, ooh, that was ugly, but infinity. So the f of x, we just said, as it's getting closer to x from the right, it's getting closer to what? Positive infinity. And as it's getting closer to positive infinity, to the right there, it's going to negative infinity because it's pointing down. Valeska. No. No, I would say a lot of people are visual and it helps, but you do not need to. You have to know what direction it's going.
So when I see log, I set x minus 3 not equal to 0.
Well, equal to 0, and that is your asymptote.
Yeah, but for the domain not equal to 0, and then I use what I got, what x can't equal as the asymptote.
Yeah. Yep.
Why do you have to put x approaching 3 from the right?
Because it never makes it to positive infinity. You mean specifically from the right or from the left?
Yeah.
Because your curve might be coming this way. You have to distinguish which side of the asymptote it's on.
But there's no curve.
There is a curve.
Or there's only one curve.
Right, but it could be on the right-hand side or the left-hand side. You have to say which way is it supposed to be. You have to have it. Because how do you know if you're coming from the right or the left? How do you know if your curve's on the right or the left? That's how you know, is by saying from the right or from the left. It's part of your limit notation. It has to be there. All right, go to B. Now it says, all right, this says ln, right? Oh, pause. All right, this says ln, but ln is a log. It's just log base e. So a log base e is pretty much the same thing as log base 3, because e is like 2.7. It is Euler's number, okay? So do you need to know that for anything other than the overall shape? No. Do we need to know what the base was here to graph this, at, like to find the intercepts and all? I mean, not the intercepts, to find the vertical asymptotes and stuff? Nope. So if I look at this, what is important and different is this order has switched, right? It is now 4 minus x. So if I wrote that in the order it normally goes, it would be log base e of negative x plus 4 plus 3. Don't let that get you. That negative is on the x. So talk about the translations here. What does that negative do? Flips it over the y. Now that plus 4 is affected by this minus x, right? Because if I actually solve that, I'd subtract the 4, but then I'd have to divide by negative 1. So even though it says plus 4, you're actually going to the right 4. Because if I set negative x plus 4 equal to 0, I'd get, I can add the x. I'd get x equals 4. So my vertical asymptote is 1, 2, 3, 4. At 4. And then up 3 means I literally shifted it up 3. So I take my graph, which normally, well, it would be flipped to the left and going through here. It would look like that. And it shifts it up 3. It does not affect your domain. It does not affect your vertical asymptote. A vertical shift just literally makes it go up. That's all. So what's your domain? Negative infinity. 2, 4. What's your range? Negative infinity to positive infinity. What's your vertical asymptote? X equals 4. And the limit notation. So now we've got the limit as x approaches. What's the furthest it's going to go to the left? Negative infinity. And I've got a limit as x approaches. What's the furthest it's going to come to the right? 4. And what side are we coming from? The left. So then f of x equals, as I go to the left, what happens to my y's? What's going to happen to these y's? They go to positive infinity. And as I go to the right, what's happening to these y's? They're going to negative infinity. Yeah.
For the negative infinity, you don't need right or left. 'Cause
Correct. You're telling it you're going to negative infinity. Yeah. You can't approach it from the left. All right, now we're flip-flopping it. Here's information. You have to determine what the log would be. I didn't see it with exponential because I feel like that would match too many other things. Yeah, because a range could basically change your... I mean, if it said it was exponential, maybe. Otherwise, it could be a parabola, right? Yeah. All right, so the end behavior... Think about what's happening here. As x approaches infinity, so we're going to the right, my f of x is approaching positive infinity. So it's getting bigger, right? As it approaches negative 4 from the right. So where is there an asymptote? Negative 4. And as I'm coming from the right-hand side, it's going to negative infinity. So it's going like this. So the positive infinity had this side, and then as it approaches positive 4 or negative 4 from the positive side, it's going that way, going to negative infinity. So what would be the function of this log?
Log base whatever, right?
It could be log base whatever, yeah.
X plus 4.
X, say it again.
Plus 4.
Plus 4. So it could be any log base, unless it gave you if it gave you the x-intercept, then you'd have to know specific base. Okay. How about if it has a domain of negative infinity to 6? So 1, 2, 3, 4, 5, 6. So Velasco just asked a really good question, and I don't know 100%. But could they be mixed in? Is it going to say it's a log? Is it going to say an exponential mixed in there? I feel like you could get a which of the following could this be? And there might be a list of things in there, and in that list could be an exponential, a log, that kind of thing. So because there's a restricted domain, I'd rule out the exponential. There's no such thing as a restricted domain on exponential. So you would rule those out. God bless you. Then I'd look at the logs, and it would be like, is there one with a plus 6? Is there one with a minus 6? Is there one with a positive x? You know, like that kind of thing.
But if it's in a graph, it would tell you.
It would be more specific. Yeah. All right, so if it's got a domain of negative infinity to 6, my graph could either be going, my log, right, could either be going like this, or it could be going like this. But what do those characteristics both have? There's a reflection in which way? Over the y, which means the x gets the negative, right? So whatever that log is, it's a negative x. And then what causes the shift to the right 6 if the x is negative? It's a plus 6. Because it's coming, your domain goes from negative infinity up to the vertical asymptote. It's not on this side. Does that make sense? Yeah.
Why did you have to put that negative x? Couldn't you just...
You could also do log 6 minus x. You could do either of those.
No,
But
like, why can't you use the blue one?
both of those are over the y. This one would be a negative on the front. No, this one would be a negative.
George, please report to student services. Gabriella George, please report to student services.
This would be these, where there's just a negative on the x, because otherwise it would be going this way. I have to flip it that way. But there could have, let's just say there was a negative on the front and a negative on the inside. Now it's this guy. It would flip it upside down and then flip it over the y. So it could be either of those. Is what it is. It could be either these or this with a negative on the front. Does that make sense? It has to have a negative on the x, but it could be plus or minus this. The homework, one of them is open-ended, and then on the AP Classroom, it's multiple choice.
How would I know when to just,
It doesn't matter. They're both right. These are equivalent. Those are the same. It doesn't
No,
matter.
but like I'm saying, x minus 6 instead of negative.
Oh, x minus 6 is just a shift to the right, but your curve would be this way. So your domain would be 6 to positive infinity.
Okay, that makes sense.
Yeah? All right. Last one, and this says sketch the graph based on the transformations. So I give you the original one. This is log base 2 of x. Now you got to sketch these 3. You try it. All right, let's start with A. So what's the 2 on the front do? It's a vertical stretch. What's the minus 3 doing?
Right 3.
Right 3. So I'm taking my vertical asymptote, which is at 0. I'm shifting it to the right 3. And I'm making this stretched a little bit taller. Good on that one? Yes? Okay, yep.
It doesn't have to be exact.
Nope. Not when it's transformations. Yep. All right, B. Negative on the front. Reflection over the x. Or upside down. The plus 1. Left 1. The minus 4. Down 4. So I'm going left 1 with my asymptote. I'm flipping it upside down and I'm going up 4. So instead of it being like down here, I'm going up 4, but it's still going to eventually cross. And I'm flipping it upside down, so it's going to look something like that. This would be actually higher, because if you're, or it's close enough. Then the last one. What's happening inside here?
A reflection across the y.
Over the y. How about the 4?
Shift to the left.
To the left 4, because it would be negative x plus 4, right? I would move this, and then I would change the sign. So it's actually going right 4. Then,
Down, up 3.
Up.
2.
up 2. So right 4 means my asymptote shifted. Sorry. Shifted 4. And then I go over the y, so I go the left, and I make it taller. Something like that. Questions?